Krebs cycle. Oxidation and decarboxylation of citrate, which is 6 carbon, to an oxaloacetate, which is 4 carbon. At the same time, we produce reduced coenzymes, NAD and FAD, and we produce carbon dioxide by decarboxylation. So the oxygen in the carbon dioxide has nothing to do with the oxygen you breathe in. 1 ATP is produced by substrate level phosphorylation, that is the direct production of an ATP. The whole process occurs in the matrix. So we had a 3 carbon pyruvate that was produced by glycolysis. Remember, that got decarboxylated in the link reaction, and it also got dehydrogenated, removing 2 hydrogens that were picked up by an NAD, forming an NADH. That left us with a 2 carbon compound called an acetyl, which joins with a coenzyme A. Now that delivers the acetyl to a 4 carbon compound called oxaloacetate. We'll call it OXOA underneath. Now the 4 carbon joins with the 2 carbon to produce a 6 carbon compound called citrate. The coenzyme A is recycled and goes round and picks up more pyruvate and acetyl. Now all of this process occurs in the mitochondrial matrix. Next step is that the citrate is decarboxylated, losing carbon dioxide. Remember, the oxygen here has absolutely nothing to do with the oxygen you breathe in. 2 hydrogens are picked up by an NAD, forming a reduced NAD or NADH. Now remember, the purpose of the NADH is that it's a carrier molecule and it carries the electrons to the inner mitochondrial membrane, because this process is all occurring within the matrix of the mitochondria. The electrons from the NADH go down the chain of carriers on the inner mitochondrial membrane, join with oxygen and hydrogen to produce water. The role of oxygen is as the final electron acceptor in the electron transport chain. Now, the movement of those electrons cause protons to be moved across the membrane from the matrix into the intermembrane space. The intermembrane space is the gap between the inner membrane, often known as the cristae, and the outer membrane of the mitochondria. The purpose of moving those hydrogen ions is that those hydrogen ions then flow out through ATP synthase, and that generates ATP. So we had a citrate going to a 5 carbon compound being decarboxylated, and then the same thing happens again. It gets decarboxylated, loses a carbon dioxide, produces 2 hydrogens, and those hydrogens join with the NAD to again form an NADH. Again, the purpose of the NADH is to carry the electrons to the electron transport chain to recycle, regenerate the NAD. Produce a 4 carbon compound. That then produces an ATP directly through substrate level phosphorylation. So the ATP is produced directly, where there is 1 produced per turn of the Krebs cycle, and that's by substrate level phosphorylation. Then there is another step of dehydrogenation, where 2 hydrogens are removed, and these are added to another coenzyme, which is the coenzyme FAD. Again, the FAD becomes reduced, forming FADH, and that FAD then goes off again to the electron transport chain on the inner mitochondrial membrane. Yet again, delivers electrons. Electrons go down the chain of carriers. However, FAD moves less protons than NAD does, so an FAD will only generate 2 ATPs, whereas an NAD will generate 3. We've now got a 4 carbon compound This then changes into another 4-carbon compound with again another dehydrogenation step, where again they're picked up by the NAD, again reducing it to NADH. That NADH again goes to the electron transport chain, delivers its electrons, pushes protons across the membrane, and at the end of it the electrons join with oxygen to produce water, and then the electrons flow out through ATP synthase, producing more ATP. Finally, the 4-carbon compound gets turned back into oxaloacetate. So, big picture, slightly bigger picture than that, we have all of this occurs in the matrix. The pyruvate enters through a carrier molecule, gets decarboxylated, dehydrogenated, hydrogens join with NAD, forming NADH. Again, these go off to the electron transport chain. This part of the reaction is called the link reaction because it is the link between glycolysis and the Krebs cycle. We have the acetyl-CoA, 2-carbon compound, 2-carbon acetyl joins with the 4-carbon, produces citrate. The citrate gets decarboxylated by a decarboxylase enzyme, producing carbon dioxide, dehydrogenated by a dehydrogenase enzyme, producing NAD. This happens again, and then an ATP gets produced by substrate level phosphorylation. Then we produce an FADH, again goes off to the electron transport chain. Again, the electrons end up joining with oxygen to produce water. Finally, we produce yet another reduced NAD, and we end up back with oxaloacetate. Thank you very much. I hope you've enjoyed it. Please subscribe, and thank you for watching to the end.